Chapter 1, Introduction to Simulation, Part 4. So in this part, we'll have the simulation by hand of the example that I have described in the previous part. So this is actually the form that we can do the simulation by hand in this form. So as you see here, we have the system status here. Let me show by different color here. Yeah, this is the area of the system status. So we have the clock here. We have the value of the BT. I mean the server status, which is could be busy or idle here. And we have the other set variable here, QT, the number of customers or parts in the line. And then arrival time of the customers in queue, again, we have it here. And here we have the event calendar or FEL. You will see this. And also we have other informations here, number of completed waiting times in queue, total of waiting times in queue, area under QT, area under BT, and here we have two graphs you'll see here, and here we have inter-arrival times and service times. Okay, so let's start. So here we set time the clock be 0 and we initialize the system. So as you see here, we have an event calendar or FEL. As you see here, we have event number, which is part number 1. The time would be 0 and the event type will be arrival. So we're going to have the first arrival of the new customer or new part at time 0. And the next event now will be the end, which will be occurred at time 20. So this is our FEL at time 0. So the first event is an arrival at time 0 and part number 1. So here we have at time t0 we have the arrival of part number 1. So as you see here, part number 1 is in the system, and since the machine or server is idle, so it goes directly to the machine and service is started, right? So clock is 0 at the time, BT is 1, so the server is busy. There is no part of customers in the line, so QT still is 0. And as you see here, in the BT graph, the value of BT jumps from 0 to 1 at time 0. Okay, and this is our new FEL, feature event list. So we'll have the next event will be again the arrival of part 2 at time 1.73, and the other event will be a departure of part number 1 at time 2.90. Okay, and the other event would be the end of the simulation, which will be occurred at time 20. Okay, so we have 3 events in our event list, and we have ordered these 3 by their time occurrence, and the top record will be the next event. So now time is 0, so we know that there will be no change from 0 to 1.73 when we will have the arrival of new part. So we actually jump from time 0 to time 1.73 in order to have the next event. Okay, so here time jumps from 0 to 1.73, and we have part number 2 in the system as well. So since the server is busy, so this part will wait in line. Okay, so as you see here, clock here is 1.73, BT is 1, server is busy on serving part number 1, QT is 1, so there will be there is 1 part in the line, and the arrival time of the customers in the queue is 1.73. Okay, and this is our new FEL. As you see here, the next event will be departure, which are going to be happen at time 2.9, and it's for part number 1. And the arrival of the new part or new customer will be at times at 3.08, which is customer or number or part number 3. And the other one, the other event will be again end event, which will be occurred at time 20. Okay, so based on the order that we have here, the next event is departure of part number 1 from the system. Yeah, again here, as you see here, Qt was 0 from time 0 to 1, time 1.73, and at time 1.73 it jumps to a value of 1, and the Qt and the BT was 1 at time 0, and it remains constant up to 1.73. Okay, so this is our status at time 1.73. So let's jump from time 1.73 to 2.9, because there will be no change from 1.73 to 2.9. Okay, at 2.9 we have the departure of part number 1. So part number 1 departs the system, and part number 2 goes to the machine. So as you see here, machine is processing part number 2. Time is 2.9. BT still is 1, but Qt becomes 0 because there is no part in the line. And again, this is our new FEL. The next event will be arrival at time 3.08 for part number 3, and the other one will be departure for departure of part number 2 at time 4.66, and the last event will be end, which will be occurred at time 20. Okay, so again, based on this order, the next event will be an arrival of part number 3 at time 3.08. So again, since there will be no change from 2.9 to time 3.08, so we jump from 2.9 to 3.08. Okay, as you see here, we have part number 3 in the system, and since the server is busy, it stays in the line. So clock is 3.08, BT is 1, QT is 1, and again, this is our updated FEL here, and you see how the QT and BT actually changes over time here. Okay, so based on this FEL, the next event will be an arrival of part number 4 at time 3.79. Okay, so as you see here, we have part number 4 in the system as well. So we have 2 parts waiting in line. Clock is 3.79, BT is 1, server is busy serving part number 2, and QT is 2. We have 2 parts waiting in line, and this is again our updated FEL at this time. The next event will be arrival of part number 5 at time 4.41. Okay, and again here you see the change of QT over time here, and also BT. Okay, so at time 4.41, again we have another arrival of part number 5. So as you see here, we have actually 3 parts waiting in line at this time, and this is again our updated FEL and change in the queue. As you see here, it jumps to 3 at this time, but the BT remains busy at this time. And the next event based on the FEL will be a departing of part 2 at time 4.66. Okay, so part 2 departs the system, part 3 goes to the machine, and as we hear, QT drops from 3 to 2. Okay, and this is our updated FEL at this time. The time is 4.66. So the next event again will be a departure at time 8.05. So as you see here, there will be no change from time 4.66 to 8.05, and yeah, and 8.05 we will have a departure event. Okay, so time is 8.05. Actually, we had the departure of part number 3, so part number 4 is in machine now, and part number 5 is still in the line, and this is our again updated FEL, and you see here again the change in the system state here. Okay, so the next event will be again departure of part number 4 at time 12.57. Wow, as you see here again, there is no change from time 8.05 to 12.57. Okay, so we jump from to time 12.57. Part 4 departed the system, part 5 is on the machine now, so QT becomes 0. Again, you see here the change of QT over time, but BT is still 1. The machine is busy, still busy serving part number 5, and wow, as you see here again, the next event will be a departing of part number 5. Okay, so which is in time 17.03. so we again jump from 12.57 to 17.03. okay, yeah, now time is 17.03. part number 5 has departed the system. There is no part in the line, so server becomes idle, line becomes actually empty. So again, yeah, here again you see how the QT and BT changes. So at this time BT becomes 0, okay, and also Q becomes 0. So this is our updated FEL. The next event will be arrival of part number 6 at time 18.69, and the other one will be end at time 20. Okay, so we jump from 17.03 to 18.69. Now again, time is 18.69. As you see here, we have part number 6 in the system. Server is idle, so it goes directly to the machine, and BT becomes 1 or busy. There is no part in the line, and again, as you see here, you see how the QT and BT are changing over time. And this is again the updated FEL, and the next event will be an arrival at time 19.39, and that will be for part number 7. okay, so we have part number 7 at time 19.39. server is busy, so it should wait in the line, and now BT and QT both are 1, and this is our updated FEL. So the next event will be the end. So we're going to end the simulation at time 20. Okay, so yeah, this is time 20, and we end the simulation. So at the end, we have 2 parts in the system, but we're going to shut down the machine, and processing the part 6 will be continued actually in the next day, let's say. Yeah, so this is our simulation, and you saw that how we can do the simulation by hand. So we will have a simpler version in the next chapter. You will see without drawing these graphs and have less information, so it will be much easier to track by hand. You will see that, but the purpose of this example here was just showing you that how a discrete event simulation works. Okay, so as you see here, the main thing here is having the FEL, the event calendar or feature event list, and by knowing the time of occurring the events, we order them, and then we jump from time to time based on the occurrence time of the events, and we process the impact of happening those events in the system, and then at the end we'll have the system state over time. Okay, so after ending the simulation, we can summarize the results. For example, we can calculate the average waiting time in queue, right? So the total of time in queue divided by the number of times in queue. So as you see here, it's 2.53 minutes per part. So yeah, we have 2.53 as the average waiting time per part. Okay, and the time average number in queue, again, we can calculate this by dividing the area under QT curve by the final clock value, which is 20 here, so which is 0.79 part. So this means that we expect to see 0.79 part in the line over time in average. Okay, and we also can calculate the utilization of the machine or server, which is a drill press here, and it will be calculated by this, dividing the area under BT curve by the final clock value, 18.34 divided by 20. Again, it's 0.92 and it's dimensionless. So here we say that in average, in 93% of times, the machine is busy, the machine is working. So this is the utilization rate of the machine or drill press here. Okay, so that was an example of a simulation by hand, and we will see more in the next chapter. Okay, so that was this part, and in the next part we will wrap up actually the process of simulation of discrete event systems. Okay, thank you.